Okay, so we are now class on example number 11. So based on our diagram, we are given here the magnitude of the force F, which is equivalent to 200 newtons. We are also given class the angles with respect to Z and with respect to Y. Okay, which is, if you could recall, this 45 degrees here, since this is the angle with respect to Z, this is our gamma, and this 60 degrees, which is respect with Y, is our beta. Okay, what is asked in this problem, class? In this problem, we are asked to express our force as a Cartesian vector. Okay, Cartesian vector. So F as Cartesian vector. So how are we going to do that? Recall that in order for us to express a vector in Cartesian notation, it should be in what format? It should be, if we have here vector A, so it should be AXI plus AYJ plus AZK. That's our format, right? So since we are dealing here with force, so our force should be in this form also. FXI plus FYJ plus FZK. Okay, now how are we going to find its x component, y component, and z component? Now, if you could recall, class, in our discussion in the Cartesian vector representation, okay, we can be able to solve for the x component, y component, and z component just by using the angles. How? If you could recall, from this format, cosine of the angle alpha is equal to x component over the magnitude of vector A, right? While for the cosine beta, we'll be able to solve for the y component by dividing it by the magnitude. And the same with our cosine gamma. So we'll be able to solve for the z component divided by the magnitude. Now, based from our given force, so we can also solve for the y component, z component, x component. But take note that we are only given here gamma and beta. We are lacking with alpha. So how are we going to solve for it? Now recall also that cosine squared alpha plus cosine squared beta plus cosine squared gamma is equal to 1, right? So since given beta and gamma, we can solve for alpha. By how? So transposing cosine squared beta and cosine squared gamma to the right side of the equation, so our equation will become 1. This will become negative, so cosine squared beta. This will also become negative, so cosine squared gamma. Okay, so in order for us to have alpha only, so since cosine squared, to recall that cosine squared alpha is simply cosine alpha squared. Okay, so we have to get the square root of this. So we'll have square root and then square root of this. So you'll have cosine alpha and you'll have square root of 1 minus cosine squared beta minus cosine squared gamma. Okay, so let us first what do you call this, evaluate this expression, this radicand here, by substituting our values of angle. So square root of, so we have 1 minus cosine beta is 60, so you have to square it last, minus cosine Gamma is 45 squared. There. So take note, class, that in this case, since we are getting the square root, if you could recall, in a square root, how many values can we get? There are two, which is the positive and the negative part. So whatever value here, it has positive and negative value. Sorry, my light is there. Okay, there. So using your calculator, class, so square root of 1 minus cosine 60, and then you have to square it, minus cosine 45, then square it. There. See? 1 minus cosine 60 squared, and there. So equal sign, you'll have 1/2, or that is 0.5. So since we have positive and negative, so we have two values, class. Two values of alpha. Okay? And to get that angle, so you have to get the arc cosine. So alpha here will have two values. Okay? You'll have arc cosine positive 0.5, and the other one is arc cosine negative 0.5. Can you follow, class? So what is the value of your alpha if you use the positive? So arc cosine 0.5. I am sorry. This one. How much? 60. It is 60 degrees. While if you use the negative side, you'll have cosine negative 0.5. There. See? You'll have 120 degrees. Okay. Now, you have to choose. Okay? You have to choose what is the correct. Although, class, these 60 degrees and 120 degrees are both correct. But the question is it appropriate in our figure? Now, let us go back to the figure. What do you think? Is it the location of the alpha, as you can see there, is, of course, it's from the x-axis towards the force F, force or the vector F. There, do you think, what do you think? Is that 60 degrees or 120 degrees? So by inspection, class, okay, by inspection, our angle should be what? Our angle should be 60 degrees. Why do you think, class? Recall that alpha should be in the positive x-axis. So our alpha is in the x-axis, positive x-axis, as you can see there. So if we use the 120 degrees, it's already on the other quadrant. Can you follow? Because, class, if you could recall in our Cartesian, or in a Cartesian, this one, okay, this is 90, right? This is 90, but if you over that, this is already, if you measure 120, this is already that, which means it is already on the other quadrant. So therefore, since alpha is in the positive side, so which means that it is only up here, something like that. Do you get my point, class? Do you get my point? So it should be, if in our figure it is located in the positive, so your angle should be between only 0 to 90, something like that. But if it is over, so it could be that the angle is negative. Okay, class, it's okay. There are problems that uses 120. Okay, there's nothing wrong with it, but what am I emphasizing here is we are trying to express a given vector already. So we are basing our answers from the figure. Again, I'm emphasizing that both of these angles are correct, But this 120 degrees is already located in the negative axis or negative x-axis. If this is our three-dimensional, this is the y, this is the z, and this is the x. If this is our positive x, okay, so this is the 60, so the 120 is already here, or something like this here, this part right here. Can you follow? So it's already out of the positive x-axis. Okay. So you have to base the value on our figure. So 60 degrees, this will be our alpha here. So using this alpha, so we will now solve for the x component of our force. So using the formula, cosine alpha is f of x all over the magnitude of f. So f of x is simply magnitude of f cosine your alpha, which is 60 degrees. By the way, class, let us check first if it will equal to 1. We have to check first. By the way, can I erase this one? Let's erase this one. Let us check first before we compute for the x and y components and z component. Let us check first using this formula if our 60 degrees is correct. So cosine squared 60, cosine squared 60 also, plus cosine squared 45 degrees. It should be equal to 1, class. Okay, but if it is not equal to 1, which means that our value is not correct. So cosine 60 squared, cosine 60 squared plus cosine 45 squared. Ayan. See? It is equal to 1. So therefore, it is correct. Okay? Now let us proceed with let's go back here. So substituting, class, the magnitude of force is 200. So cosine 60. So you'll have 200 cosine 60. Cosine 60. That is 100. So 100 Newton. Okay? That's our x component. Can you see it? This one. There. Now how about for the y component? For the y component, let me erase this one. For the y component, so our cosine beta is y component divided by the magnitude. So y component is magnitude times cosine beta. So 200 Newton cosine, your beta is 60. So it's somewhat the same here, class. So we will have also 100 Newton for our y component. Now how about for the z component? So cosine gamma, z component over magnitude. So z component is magnitude times cosine 45. So 200 Newton times cosine 45. This is how much? 200 cosine 45. There, you'll have 141.421 Newton. Okay, class? So that's it. That's it, our x, y, and z component. Now we have to express it in the format or in the format. So I have to erase this first. So following our format, class, which is, what is it again? So f is fxi plus fyj plus fzk. So our f of x is 100. And then just write I plus your fy is still positive, so 100. And then copy the j. And then your z component is positive also, so just copy it 4 to 1 and copy the k. And don't forget the unit. So class, this is already our force expressed in Cartesian vector notation. Now, how are we going to check if it is correct? How are we going to check if it is correct, class? When we say correct, is our expression correct? Because our given is 200 newtons. So if you want to check it, okay, checking. Recall that magnitude of force is square root of fx squared, fy squared, fz squared. So since our given is 200 newtons, so it should be equal, class. Okay, so we have here 100 squared. We are trying to check, class, ha? Plus 141421. So we have to check if it will be equal to 200 also. Because, class, once that is not equal, which means our answer is wrong. Okay, so let's check. Square root of 100 squared plus 100 squared plus 141.421 squared. Okay, is it correct now? So, okay, so equal. Okay, so 199.999. There's a slight 9997. There's a slight what do you call this? Slight difference in decimal. Why, class? It's because we have rounded off in this part. But if we copy the whole value, we will come out with the same value here. So this is correct, class. Okay, again, we just check it if our solution is correct.